Antarctica is a desert. The driest, windiest, coldest, harshest place on Earth. It's almost twice the size of Australia and colder than the Arctic. The temperature gets as low as -90 degrees Celsius and wind speeds as high as 300 kilometers per hour. Summer days are 24 hours long, and in winter, nights can bring an entire month of darkness. It is here that we get the best window on our geospace, combined with an unspoiled physical environment hoarding millions of years of evidence describing the Earth's history. It has a unique system of government. Antarctica belongs to no one. An international treaty gives all countries the right to study this pristine environment and protects it as a natural reserve devoted to science and peace. The hostile environment makes life here extremely difficult. But despite its inherent dangers, researchers from at least 30 countries occupy the continent at various bases. As one of the original 12 signatories of the Antarctic Treaty, South African researchers have been working here continuously since 1960. The South African National Antarctic Expedition Base, SANAI 4, is the platform for South Africa's contribution to Antarctic research. Maintaining a base in Antarctica poses huge logistical challenges for the transportation of personnel, equipment, hazardous cargo, and supplies. For close to 35 years, the South African Department of Environmental Affairs Research and Supply vessel SA Agulhas has been the lifeline to operations here and on Marion and Gough Islands. With the SA Agulhas reaching the end of its working life for such punishing conditions, DEA took the decision to replace its flagship with a new purpose-built vessel to take over these duties using the latest technology. This ship would have to be a tanker, cargo carrier, passenger ship, research vessel, helicopter carrier, and an icebreaker. Such a vessel has never been built. After exhaustive studies, reviews, expert consultations, and a tender process, one company emerged as the frontrunner. STX Finland, the builder of the world's largest passenger cruise ships and with one of the longest histories of icebreaking experience, was chosen to undertake this pioneering work.
The competition was international. The client visited several yards abroad, and our benefits, as they have always been, has been one of designers, and we have all our elements in-house. We can make the design here, we have the production facilities, we will do the testing and final commissioning.
DEA vessel is of course one of vessel, and it's prototype vessel, and this is the first passenger vessel including all this Ice-10 class and helicopter facilities and cargo facilities. So this is very unique.
With a ship of this type, you spend probably almost as long in designing the vessel as you do in fact building it. This one in particular being the first of class, the first of its kind, took nearly 9 months to do the detailed design and get all the drawings approved, not only by the owner, but by the Classification Society and all the other regulatory authorities.
STX Finland's Rauma shipyard is one of the world's leading ferry builders, and their location close to the Arctic makes them the ideal shipbuilder for icebreaking vessels. Located on the Finnish west coast, the quaint town of Rauma, known for its high-quality lace and 18th century buildings, has a proud maritime history. Here, the first steel for the project was cut in September 2010. Raw steel plates are computer engineered and cut with absolute precision using CNC plasma cutting technology. These components are then welded together in incremental stages to form larger sections.
We start from small pieces of steel and building smaller sections of that, combining the small steel sections into bigger ones, and then combining the two blocks to a jumbo block which may weigh close to 500 tons.
STX Rauma's massive sheds ensure that this work continues all year despite sub-zero temperatures outside. Cabins are prefabricated to design specification, and progress is monitored closely to ensure that all electrical and logistics prerogatives are met.
All the cabins are on the port and the starboard side of the vessel, which then allows natural light to come in. Every single cabin has their own ablution facility. Also, 90% of the laboratories are with natural light, which also makes a huge difference when you're spending a lot of time at sea.
We've looked at most suitable bits of equipment that is always going to be available in South Africa to ensure that the flow of spares is not interrupted. We can always get stuff when we require them.
Daily inspections are conducted on-site by the project team along with independent specialists who scrutinize every detail of the build process. An icy finish morning in January 2011 saw the placement of Finnish and South African coins under the first block during the keel laying ceremony.
This keel laying block will be lifted as a first block to the dry dock on week 9, and then it's like a Lego puzzle to lift next sections front and aft and above this.
The ship comprises 26 what they call grand blocks. Those are big structures like the one behind us, and then the ship is constructed in the building dock. Each of the blocks are then put together. They put in the bottom of the yard, completed. They pushed together, aligned, and then welded up.
A major milestone of the build is the installation of the ship's engines. 4 6-cylinder Wärtsilä 32 diesel engines make up the main power generation system. Each engine generates 3,000 kilowatts of electric power for the two 4,500 kilowatt electric propulsion motors, each driving a variable pitch propeller.
During 20 weeks we have lifted all the blocks, so putting those 30 blocks together we have created this complete shape of the hull.
In July 2011, the DEA Director General, Mrs. Nosipho Ngcaba, presided over an emotional naming ceremony for the SA Agulhas II.
I was moved and I was thinking, is this a dream or am I really alive? And I pinched myself a little bit to feel that, yes, this is the day and I'm here in Roma cutting the ribbon on a South African special vessel.
So it is with excitement. Also, I guess, with anticipation, because we are going to be opening a new window in terms of our understanding of what happens in the oceans.
So there is now inside the vessel, there is plenty of areas where is pipe fitting work going on, insulation work going on. There is already a lot of cabins inside, and that work starts to continue simultaneously with the hull assembly.
From now on, of course, all the main machinery is in place, and some of the infrastructure on board the ship is at quite an advanced stage. And now starts all the outfitting, the fitting of the cabins, fitting of all the galley equipment and the galley itself, the fitting out of the laboratories. They're all there just in steel at the moment.
Many miles of cabling line the internal walls, floors and ceilings, transporting critical data throughout every corner of the ship. The main point of command is the bridge. Control for all the ship's systems feed back here. There's extensive equipment for communication and navigation. The ship is fitted with a satellite dish to serve the communications needs of the passengers and scientists. This will provide capacity to send large volumes of raw data from surveys for further processing ashore by specialists. Once all critical systems have been installed and are ready for testing, sea trials await.
The objective of the sea trials is really to, for the first time, put all the systems in the ship under test under real conditions rather than alongside the harbour. And that really means testing everything.
Every system must be rigorously tested under the scrutiny of certification and safety authorities, Det Norske Veritas, and the South African Maritime Safety Authority and the department's project team. Tests include maneuvering trials, engine load tests, autopilot and dynamic positioning, and noise and vibration levels. All scientific equipment must also be demonstrated by manufacturer representatives. A drop keel can be lowered through the bottom of the ship to a depth of 3 meters below the keel. It houses the transducers for measuring the density of plankton layers, small fish, and ocean currents. The large environmental hangar door can be opened at sea to facilitate the operation of deep water probes to a depth of 6,000 meters. The ship has deep coring facilities for geological science, capable of sampling seabed sediments to a depth of 5,000 meters. A hydraulic A-frame on the stern allows for towing sampling nets and dredges and deploying or retrieving current meter arrays. A moon pool extends from the environmental hangar down through the ship's hull. It can be used as an alternative launch area in pack ice. The shape of the bow is critical for breaking ice. The bow was designed in Rauma and refined by subsidiary company Aka Arctic in Helsinki. Aka Arctic has the world's only privately owned ice model testing facility and has been involved in 60% of the world's icebreakers. This engineering would now be put to the test as the vessel is taken north to find ice during the ice trials.
We have specified in a ship specification that the vessel will achieve 5 knot speed at 1 meter ice. And that was, of course, the main issue what was tested, and she did it.
During the ice trials, ice samples are collected and extensively tested for density, thickness, and brittleness.
We went up to the north of the Gulf of Bothnia, which gave the ship a real run, where the density was very low, so the ice was of a very hard condition. And the vessel performed extremely well in those ice conditions, surprisingly so.
The finished product was proudly handed over on the 4th of April 2012 during a poignant flag-changing ceremony signifying its transfer to South African ownership. With just 2 days to complete final preparations and pack supplies, the vessel is finally ready to leave its moorings and come home to fulfill its important role.
That was maybe one of the more moving moments of this entire process, was to see the ship moving off the quayside and then realizing in 2 hours' time that berth would be empty and the ship would not return. It was really a moment for myself and the STX.
The ship was delivered to specification, to budget, and on time. And those are the 3 things we like our customers to conclude when they leave here.
On the 3rd of May 2012, the SA Agulhas II sailed into Cape Town Harbour to jubilant celebration. The ship was traditionally blessed and dedicated to South African musician and activist Miriam Makeba, the Empress of African Song, who devoted her life to the struggle for human rights and the opposition of tyranny. The arrival of SA Agulhas II ushers in a new era of scientific discovery for South Africa and sets the benchmark for vessels conducting this essential work.
It will act as a catalyst to draw in international expertise and in the process build local capacity. So we're very excited about that.
I think that we are incredibly blessed to have this vessel. It's a privilege.
It's been the most exciting project that I've ever had the privilege to be involved in. And in some ways I'm sad that it's coming to an end, but on the other side it's a huge sense of relief and a sense of pride that we have got to where we've got to.
As we say farewell to its stalwart predecessor, the SA Agulhas II capably assumes responsibility for South Africa's contribution to Southern Ocean and Antarctic exploration.